Okay, so today we're going to go through two more ways to prove triangles congruent. Remember I said there were 5 altogether. We previously did side, side, side. Now we're going to add 2 more, kind of like shortcuts. Remember, you don't need every piece of a triangle to say they're congruent, just certain ones in certain orders. So today we're going to go through 2 more ways to prove triangles are congruent. Now, kind of a new term we have is included angle. It is the angle between 2 sides. So you can see that kind of in the picture there. So again, included means in between. So basically the angle has to be surrounded by the 2 sides. The angle must be touching the 2 sides. So the next way we're going to add to our congruence postulates is side, angle, side. So if you have 2 sides and the included angle of one triangle, if they are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles, lo and behold, are congruent. So this is called side, angle, side, because you have a side, then included is an angle, and then you have another side. So let's see here, and this diagram is a good picture of side, angle, side. And it is the same over here, side, angle, side. If side RS is congruent to UV, and angle R is congruent to angle U, and RT is congruent to UW, then triangle RST is congruent to UVW, triangle UVW. And again, remember, this order does matter, so make sure if they went RST, you've got to go in the same direction and go UVW. The vertices must be aligned. So in a proof format, we're going to use the side, angle, side congruence postulate, and we're going to write a proof. So BC is congruent to DA, so we're going to write that. Remember, whatever's given is what we rewrite in the first step. That's given. Let's make sure it's marked. Yes, BC congruent to DA. Also, BC is parallel to AD. Is that marked for us? Yes. As you can see, the triangles there are marking its parallel. So the next statement, it says that angle BCA is this angle here, and DAC is this angle here. They're telling us they're congruent, so they are, but now we have to know why. So this case is a pretty good example of why you definitely need to mark your picture so you can see what's going on here. All right, so remember I said everything we've learned in the past is all fair game. You have parallel lines. Then you have this transversal cutting through, so those angles listed are actually alternate interior angles. So all of that's going to come into play again. Yes, I know you're ecstatic. Next, we're looking for a statement that will satisfy the reflexive property. Well, we have 2 triangles touching up against each other. So remember, anytime you do that, if they touch, then you have the side in common is congruent to itself. So side AC is congruent to side AC. You always want to ask yourself, do you have enough information to prove the triangle's congruent? Let's see, we have side, then we have this included angle, and then we have another pair of sides. So yes, the triangle ABC is congruent to triangle CDA because of the side, angle, side congruence postulate. Excellent. Now let's move on to right triangle. So let's remember, in a right triangle there are always 2 legs and there is 1 hypotenuse. So the next method we're going to add, so we have side, side, side is a way you can prove triangles congruent, side, angle, side, and the next one is going to only be used for right triangles, and it is called hypotenuse leg, or HL. So again, this HL is going to stand for hypotenuse leg. So, all right, so if the hypotenuse and a leg of one right triangle are congruent to the hypotenuse and the corresponding leg of a second right triangle, then the two triangles are congruent. So again, let me break that down for you. You're going to have the hypotenuses are going to be congruent. And then one pair of the legs are going to be congruent. It doesn't matter which pair as long as they're the corresponding legs that are congruent. So let's look at the hypotenuse leg, congruence postulate, and a proof. So we have a bunch of stuff given to us here. So remember, the first step in a proof is always to rewrite the given. So AC is going to be congruent to EC. And remember, if it's not marked, we're going to mark it. But that is marked for us. AB is perpendicular to BD. Let's go ahead and mark that. So AB is perpendicular to BD. Keep going. ED perpendicular to BD. Mark that. ED to BD. Last, that was given. AC, and I'm just going to abbreviate, is the bisector of BD. So this one's super important because you got to remember what that word bisect means. And bisect means cut in half. So if AC right here is the bisector, then it's going to cut that segment in half. So now let's look at number 5. It's telling us now that angle B and angle D are, and we have marked here, see, this is why it's important to mark your picture, because perpendicular, we have marked them to be 90-degree angles, or they're right angles. They are right angles. And how do we know they're right angles? Is because that's the definition of perpendicular lines. Perpendicular lines meet at a right angle. Also, next, the statement is triangle ABC and triangle EDC are, what type of triangles are they? They're going to be right triangles. Because remember, hypotenuse leg only works in right triangles. How do we know they're right triangles? Well, because that's the definition of a right triangle. A right triangle has a right angle in it. Again, remember I said like the reasons are a lot of like you see them like it's common sense, like you already know it, but it's just kind of like you are having to explain yourself. Okay, next in the statements it says BC is congruent to. Well, if you see again, we've already marked it. Because of all this information being marked, it's easy to see that BC is congruent to CD. The reason those two pieces are congruent to one another is because that's the definition of a segment bisector. Again, I said you'll get used to the reasons, and it's the obvious reason. So don't try to think of something new. You marked these being congruent because it told you it was a bisector. So then that's the definition of bisector. Now you can see the HL. So you see we have the hypotenuses of each triangle, and we have a pair of legs, which are the same legs in each triangle. So hypotenuse leg is why these two triangles are congruent to one another. HL. And lastly, state if the two triangles are congruent by side angle side, HL, or neither. So if we look at the first one, we have here, these are the hypotenuses of the triangle. I see it's a right triangle, but do you have another pair of legs? Remember, anytime two triangles are touching, they're sharing that side. So yes, they're congruent by HL because ON is congruent to ON because it's reflexive. Perfect. Next, we see they're sharing a side, so we're going to mark that immediately because of reflexive. We look at one triangle and we have a side angle side. So they're all consecutively touching. So side angle side is in this triangle. If we look at the other triangle, we only have one angle and one side. So since we don't have enough information here, then these are not congruent. Because the triangles must have the same pieces in order to be congruent to one another. Oh, this one is a doozy. So, we remember everything I told you, everything we've learned is fair game. So right off, these two triangles here are sharing a vertex. So therefore, if they're sharing a vertex, then vertical angles also share a vertex. So there's your pair of angles that are congruent because these are vertical angles. So that's another thing you've got to remember to mark. It's not missing, it's just kind of hidden. Now another thing we have here, we have a diameter which is cut in half by the center. So we can say that this piece is congruent to this one, and therefore we can also conclude here to here. So if we look at the triangles now, we have side, angle, side, side, angle, side. And you want to try to describe the pieces of the triangle in consecutive order. So side, angle, side. Like you want to go around the shortest distance where you're going to hit the next piece. So see, I would not want to go around this way because Q and P, I don't know anything about Q and P. If I'm on this side, I want to immediately go to the next piece that's congruent. So these are, yes, by side, angle, side. Next, we're going to state the third congruence that must be given to prove the two triangles are congruent by the stated congruence postulate. In number 4, we must use side, angle, side. So they give us JR is congruent to DF, JM is to DB. So what piece is missing if we must do side, angle, side? Remember the trick here is that angle must be included in between the sides. And again, included means in between. Included also means touching both of the sides. So the only angles that will work here are J and D. So angle J being congruent to angle D is missing. Next one. There's a little piece of information that's missing here, so let's go ahead. I need to give you some extra information. It was left off that JM is congruent to DB. Okay, so JM is congruent to DB. You also know that angle J is a right angle and that J and D are congruent. You must use HL. Hypotenuse leg requires that a pair of legs are congruent, the same leg, corresponding pieces, so you have that, so that we have our right triangles. What's missing are the hypotenuses, so we actually need these pieces here. We need RM is congruent to FB. That's all she wrote.